Hey everybody, Daniel here from Basement Tech. Regular viewers of the channel will remember that I'm converting this CNC Shark to LinuxCNC. This video is going to be just kind of a quick bonus video of some experimentation I did to solve what I perceived as a problem I've had on other systems as well. If you listen very carefully, you can hear this sort of buzzing noise that comes from the motors. Between the last video, which talked about the X-axis limit switches, and this video, I've swapped out the power supply from the 24 volt linear power supply to this 48 volt switcher. I also added a 12 volt switcher, that tiny little one there, to provide power for that fan that's now cooling the G540, and these limit switches, which I said I was going to talk about in the next video, but it's actually going to be the next video. What I wanted to just highlight here is something I've observed and something I'm really surprised at. That buzzing noise on the motors wasn't just making sound, it was actually heating up the motors. These motors are designed to run at a very high temperature, but it was a little bit uncomfortable for me. Being an electrical engineer, heat is always the enemy of electronics. So I scoured the internet and actually found a posting from one of the engineers at Gecko that suggested a list of things to try. Now, I've tried a few of those and they didn't help, but I did want to let you know the one thing that I think did actually make a difference. One of the early suggestions was to shorten the power supply length, the length of the lead from the power supply to the G540. I don't think I can get it much shorter than this, which is about 24 inches, and I really didn't see a difference there. He also suggested adding a capacitor. Now, I had this monster capacitor, so I just added that. And whenever you're using capacitors for filtering things, you need to get them close to the thing you're trying to filter. That's why I placed it right under the G540 with very, very short leads. I didn't see much of an improvement with that change, but I thought both of those improvements, the length of the power supply wire and adding that capacitor, would be good things long term, so I plan on leaving those in. The one that I think actually did make a difference, which was a little surprising to me, but nonetheless, I think it did make a measurable difference, more in the heating than in the sound itself, was moving the current limiting resistor from this end. In other words, it was embedded in the connector near the motor, to right next to the G540. It made sense to me, sort of philosophically, to have it attached to the motor because the current limiting is a function of the motor specs. But in the end, I guess maybe the inductance of the cable or some other factor had an influence on that. So I utilized these little breakout boards that I got from the vendor who supplied the cables. I made a video on that, and you can reference that, and move that resistor right up next to the G540. Now, these little breakout boards come with a little shell that makes them look more like a connector, so I think that's going to be a good solution in the end. When I first started noticing this heating, I thought perhaps it was the switch from the 24 volts to the 48 volt power supply. So I went back to my 24 volt linear power supply, and lo and behold, the temperatures came down, but they were the same across all of the axes. I switched then back to the 48 volt and made similar measurements, and saw that the temperatures were quite high. Now, this was after I had switched the X-axis resistor, moved the position of the X-axis resistor from near the motor to near the G540, and you can see a definite difference between the Y and the Z motor temperature and the X-axis temperature. I thought, well, okay, that seems reasonable. Let me leave the power supply voltage the same and change the resistor on the Y-axis, and that's what you see here. So in making temperature measurements with a little infrared, it's hard to do all this with just two hands. If I measure the temperature of that Y-axis motor, I see now that it's down to about 93 degrees. Last time it was over 100 degrees, 106 degrees as a matter of fact. So just to make sure, sort of as a control, that my x-axis motor continues to perform, that's still at about 90 degrees. Now X, which has not been moved or changed, the resistor is still out here by the motor. Oops, sorry, you need to see that, is at 106. Now if I change this Z-axis motor and all the motors run cooler, I think we found a little bit of a smoking gun. As I say, I'm going to leave some of the other changes in place that I made. I think they're good improvements to the system in general. So there you go, quick short video on some experimentation that I did with the position of the current limiting resistor. If you had similar problems or had similar results, please put those, reference those results in the comments, and or tell me if you believe these results in the comments.
All right, well, I think it's fair to put this experience into the Ripley's Believe It or Not, and you can decide whether to act on some of these findings based on your system design sensibilities. Gecko does have a pretty extensive list of application notes on their website, and I would recommend visiting that, reading through them, and again, making your own judgments about hardening your system to the heat of stepper motors. Here's a few bullet points that I think are true. Number one, stepper motors are designed to run warm, not just warm, but really hot, into the 100°C range, where reliabilities are stated in tens of thousands of hours, upwards of 50,000 hours in some cases. I think that's 5 years or so. Number two, my Gecko G540 is a bit older. Number three, the article that I referenced was from 2010. I don't know if things have changed in the last decade or not, but again, read the design articles, read the application notes on Gecko's website, and make your own judgments. I do intend to implement some of these things that I mentioned in this video as a way of hardening my system against heat. If you like this kind of video, please give it a thumbs up. If you really like it, subscribe and hit the notify me button.